Hi, today we'll be talking about our project, Exploring Code Switching Translation with Whisper. Hi, my name is Komal.
My name is Billy.
I'm Saleh.
I'm Nila.
My name is Gaurav.
My name is Ayush.
In our initial research, we explored the Whisper ASR system in PyDeb for audio processing. To better understand these tools, we began by recording our own audio clips. Our research, focusing on code switching, is a linguistic challenge that adds layers of complexity to the translation process. Code switching is a phenomenon where a speaker alternates between two or more languages. We aimed to tackle this challenge by leveraging Whisper's capabilities. However, it came with certain limitations. Whisper supports translations of only 30 seconds at a time, and is currently designed for translation from a different language to English, restricting its application to simple language translation scenarios. We came up with 3 ideas targeting code switchings: analyzing waveforms to identify differences and patterns in languages, modifying Whisper source codes and leveraging tokens, or the one we chose, identifying the timestamps of code switches by splitting the audio based on Whisper's probability confidence of a language.
In this project, we faced 3 main challenges. One of the primary hurdles that we faced was the task of finding applicable datasets that contain multiple languages. It was challenging to locate audio files with enough code switching phrases and sufficient length for translation purposes. We were only successful in finding 2 that were for our purpose: the KRSN for Mandarin English and an Alia Bhatt interview clip for Hindi and English. Another hurdle we faced was the choice between using a linear or binary search for our audio splitting function. This algorithm was crucial in determining the correct points at which language switches occurred and splitting the files at those exact timestamps. We ended up choosing to do a binary search for the best results. The final hurdle we encountered was determining an appropriate threshold for the probabilities of language detection. Initially, we focused on using a 90% certainty in our binary search as a stopping point for splitting the audio clips. However, the clips were unnecessarily splitting too many times, so we decided to reduce the certainty of the threshold to 60%. Ultimately, this strategy expedited the process while avoiding many unnecessary splits.
For a high-level overview of how our project works, we first take in an audio clip of any length as input. And if it's too long, we chunk that audio clip into smaller 30-second clips. Then for each of these 30-second chunks, we use a binary search to find a rough estimate of where code switches occur, and then split this chunk into smaller segments where there's just one language being spoken. Afterwards, we run these smaller segments into the base Whisper model to translate them to English. And then once everything is translated, we can then recombine these translations to get the full translation for that 30-second clip. And we do the same thing for all the other chunks, and then combine all those chunks together in order to get the final translation for the original audio clip.
Now that we've talked about our main hurdles, we can talk about our implementation. We use the Ascend dataset, which is a Chinese to English audio dataset involving lots of code switches. We primarily use this dataset while training and configuring our algorithm. However, we also did use an Alia Bhatt interview for data, since we were able to compare how well our algorithm did compared to Whisper and a person fluent in Hindi translating the text. As mentioned before, we used binary search for finding timestamps of when code switches occurred. We landed on a probability threshold of 60% of when not to split an audio clip into smaller chunks. In this scenario, we split the audio clip. They would be truncated in half and stopped once it reached about 2 seconds. Anything less, we found our algorithm had trouble identifying languages and returned inconsistent timestamping. Once we found the timestamps, we would split the original audio into smaller chunks based on those timestamps, so we could tell Whisper from here to here, this is the language that needs to be translated to English. After that, we would combine our text results and compare with the base model of Whisper and our own translations, either manually or from Google Translate.
Hello, and welcome to the demo of LingoBin. LingoBin uses binary search in order to detect code switches within multilingual audio clips using Whisper. Using this binary search method, LingoBin will break down an audio clip and use Whisper to detect the language spoken until one language crosses a probability threshold of 0.6. If that threshold is not crossed, the audio clip will keep splitting until that probability threshold of 0.6 is crossed. Once it is fully processed, this method will return a dictionary as seen here, and the dictionary will contain timestamps as seen here with a corresponding language. Here it's HI as in Hindi. We used Alia Bhatt's interview for her upcoming movie Shandar to compare results on how LingoBin and a base model in Whisper does when testing a multilingual audio clip with code switches. As seen here, for the first clip, the results are almost the same. However, as we go into the next clip, which each clip was broken down into 30 seconds, because that is how long Whisper can translate and transcribe. And if it goes beyond 30 seconds, we discover that Whisper stops transcribing. But as you see here, in this audio clip, the translation is, I will still work as hard. I will work hard and I will work hard. And the way we're doing it for the people, for the film, for the character. Alia continues to talk about her work and the feeling of the character in the movie Shandar, and the fact that she wants more directors to come to her for work. And she wants to continue doing this work for her fans. However, in Whisper, as you can see, when translated in Hindi, the translation takes the first thing that it translates, I will work as hard, and keeps repeating it on and on and on. The same thing is true for the next 30 seconds of the interview, as it translates it in Hindi and keeps repeating it. However, here, it translates it with Hindi or English, depending on what the dictionary that we pass in dictates. And here, as you can see, Alia Bhatt is talking about achieving her dreams, making a major difference, and making it in life as an actress. Now, let's go on to the Mandarin and English audio clips that we got from Hugging Face. Here, as you can see, for the first 30 seconds, we are introduced to a person named Zhu Yan, where she introduces herself in the audio clip, says that she is excited to have the opportunity to be friends with the other person on the other end, and say that there are not many opportunities to meet strangers, and she's very honored. As you can see here, the distinct difference in the translation is that it says, today I'm very happy to have this opportunity to go to make friends. In our translation, it says, today I really hope I can get this opportunity to make friends with you. This distinct difference tells us that when translating from Mandarin and English to just English, it's very important for any multilingual clip to have the right context. Here, as you can see, all of it is being translated as if it is Mandarin. Here, it's being translated given the context before. This is evident in our code, where until we detect another language, we keep translating by using the previous audio clips that weren't split to give us our final translation, and we join it together. That was all for the demo of LingoBin. Thank you for watching.
Overall, our algorithm compared to the base Whisper version was better in some regards or about the same. Whisper had some issues where it would sometimes get stuck on some parts of the audio clip and just end up repeating the same phrase over again. However, our algorithm didn't seem to encounter this issue whenever we compared it to the same audio clips between Whisper as well as our algorithm. One example is from the Alia Bhatt interview, where we actually ended up passing in a portion of the interview and Whisper's translation ended up just repeating the phrase over and over again. However, our algorithm produced a much better translation, adding a lot more context and explaining every single part of what it was saying. So overall, our algorithm was able to produce about the same results as Whisper, but in some areas we were able to improve a lot more by adding more context when translating the clip. Context can be super important whenever we're translating, so that's why this was a very integral part of our project. There's still some areas, however, where we feel that our algorithm needs improvement in to really be able to say that we're better than Whisper. First and foremost, we struggle with any clips that are less than 5 seconds, which is why we ended up choosing test cases that were a little bit longer, such as the Alia Bhatt interview. We believe that the reason for this is because of the lack of context, making it difficult to identify different languages. However, it does really well with clips around 10 to 30 seconds, and with clips exceeding 30 seconds, there wasn't any improvement because base Whisper model can only do clips of 30 seconds. Our algorithm also kind of struggled with finding the exact timestamps of the code switches, but I think this is because of our method of binary search. There weren't any other methods that we really considered, but in the future, if there was a way that we could replace this, we think that there could be a much more greater improvement in finding the exact audio timestamps. With all this said, we've concluded that our method has taken a right direction to helping translate multilingual audio clips. There's still some areas that we could improve on if given more time and resources. More testing with data sets could provide us further evidence if our approach is valid or not.